What is up, Five Keys? Mr. Mike here. Today is February 4th, 2022. It's a Friday. Today we're going to look at Module 3, Lesson 2, Solving Inequalities Using Addition and Subtraction. So we did look at inequalities with Lesson 1 in our previous lesson, and now we're going to integrate that with what we learned in Module 2, which was in the earlier part of Module 2, which was solving equations in one step, where we use the addition and the subtraction property of equality to isolate the x. We're going to do that exact same thing, but instead of having an equal sign, we're going to have an inequality. So instead of solving for x as a finite number, specific number, we're going to solve for the set of x, right? What x, all the possible numbers that x could be when there's an inequality versus an equal sign. That was a mouthful. I'm hoping that it's not as confusing as what it sounds like, because it actually just combines two ideas that we already know. What else do I want to say? Today is February 4th. I said that already. It's a Friday. There's 2 more weeks before school goes up on a winter break. And there are 10 more lessons after this one. So if we do, and by we, I mean the 5 lessons a week will be done before winter break. Super excited. All right, let's get into it, huh? No need to do an introduction, because this is, like I said before, we're just, I don't want to say just to diminish it, but we are combining 2 ideas and concepts that we've already studied. So here we go, solving inequalities using addition and subtraction. In this lesson, you will use addition or subtraction properties to solve inequalities. I will let you look at these ideas on your own. Actually, let's go over it. So this is the real world problem. In the US presidential election, a candidate must win at least, that's a key word there, because it suggests an inequality, 270 out of 530 total. Come on. Out of 538 total electoral votes to be declared the winner. Suppose a candidate has earned 238 electoral votes in states outside the southeastern US. What is the least number of states in the southeastern US that the candidate could win and still become president? What are these states? Justify your reasoning. Oh my gosh, the phone totally distracted me. I have no idea what they're talking about. But let's keep reading. So if the candidate has 238 electoral votes but needs 270 to declare the winner, we can write an equation to determine the number of votes needed as this. Well, that makes sense. I have no idea what they're talking about in that blurb, but let's keep reading. So we know how to solve this one-step equation. We know x is equal to 32. Why? They subtracted 238 from both sides of the equation. They ended up with 0 plus x equals 32, because 238 off of 270 gives us 32. But the question is asking for the least number of states or electoral votes. This question's stupid. I don't know. I don't even know what to say. I shouldn't be that rude, because someone wrote it, and I apologize to that person. It's bothering me because the states don't have an equal number of electoral votes, so it's thoroughly confusing. But it implies an inequality, so it's not simply that. Oh, okay, I'm sorry. I completely retract what they said. They're going to do a deeper dive. That's what I get for not looking over the assignment first. This implies an inequality which can be written as such. 238 plus x must be greater than or equal to 270. This means 32 would still work as a solution since it yields 270. But is that the only solution? Well, let's try some values. If they win these 3 states, they get 39. That is a solution. These 2 states, 42. These 2 states, 32. Each of these state combinations will work, but appears the least number of states is 2. All right, that I think was way more confusing than it needed to be. So let's just look at this. X plus 5 is greater than 6. So x is what? This is the first place where you need to do some work. Well, I'm going to do exactly what I would do if this were an equal sign versus an inequality, which is I'm going to subtract 5 from both sides. That's going to make it x plus 0, and I don't even need to write that in. And whatever I do to one side, I need to do the other side. This is the subtraction property of equality. We could absolutely change this to adding the opposite. This is positive 5 plus a negative 5, adding the opposite. Now we have addition property of equality. Doesn't really matter. It's both going to result in the same thing. X is greater than 1. And the solution, you would write a 1 in here. The solution graph to this identity would look like this. Why do you think the circle over 1 is open? They're talking about this circle here. The alternative would be to color it in so that it was a solid circle. But it's not, it's open. Okay, so I hope that you've done this already, this problem, and now you're just checking to see if it's correct. Okay, if you haven't, pause it and please do it. But I might say something to like, well, x cannot equal, whoops, that's not how you spell it, cannot equal 1 exactly. It can be barely bigger than 1. It just can't be 1. Anything like that is perfectly fine, perfectly acceptable answer. In what scenario would I color it in? If there were another line underneath that inequality, so it looked like this would read x is greater than or equal to 1, and then you would color in that line. Okay, moving on. Okay, to give you an example, but we'll go down to you try. If you haven't done this yourself, please give it a shot. What's the first step? I am going to set my left side of the equation equal to n by adding a positive 5 to both sides. This is module 2 stuff, same thing that we do if there were equal sign. Why am I going to add a positive 5? Well, because if I think of the subtraction sign as adding the opposite, this 5 is negative. So if I add its opposite, positive 5, the whole thing will go to 0, which is what I want. Now I have a negative 3 plus a positive 5. And I have n is equal to, this is going back to module 1, lesson 2. What do I do if I'm adding a negative and a positive number? Well, it's becomes subtraction. I take the number with the smaller absolute value and I subtract it from the number with the bigger absolute value. Subtract 3 from 5, I end up with a 2. It's a war, not a party, because the signs are different. And then, well, where does the sign, what sign is on that 2? It's the number that has the bigger absolute value, in this case, the 5, so the 2 is positive. And is less than, but not equal to 2. So here's 2 on my number line. If this is negative 2, negative 1, 0, 1, 2, 3, 2 is going to be right here. I'm going to draw an open circle because this is not or equal to, so I need to notify of that. And then I'm going to draw a line with an arrow going to the left. And I can do all that in the box right here. Okay. Solve graph and check the following. We can jump down and see if they give us a simple U try. That's similar. Yep, there's our U try. So you can go over that example on your own if you choose. Make sure to try this U try on your own before you watch the rest of the video. Okay, so what am I going to do here? Well, M is being 11 is being subtracted from M. So I'm going to think of this 11 as adding the opposite of, so I see a little bit more clearly that to make that a 0, I need to add the opposite of this negative 11, which is positive 11. And that's going to make this guy 0, which is what I want. It is greater than or equal to negative 2, but whatever I do to the left side, I have to do to the right side. Same rules as when we're dealing with equations versus inequality. So I'm going to add 11. And now I have M is greater than or equal to, I should say, -2 plus 11. Party or a war? It's a war because we have one negative and we're adding it to a positive. Which number has the bigger absolute value? 11. So I want to take 2 away from it. That leaves me with 9. And I want to adopt the sign of the number that has the bigger absolute value, in which case this is 11. And 11 is positive. So it's positive 9. Okay. I am rattling this off, and this is all like super procedural. If you want a stronger conceptual understanding of that, if you're still struggling with it, I encourage you to go back to module 1, lesson 1, 2, and 3. We'll do a deep dive into that, at least 1 and 2. Okay, so if here's 0 and here's 14, I'm assuming that these are each worth 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They are, I've confirmed it. So now I'm going to count up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to draw my circle. That's not the place where I want it to be placed. I'm going to draw my circle right over the 9. I like to do it not over, not on, so we can see it clearly. And I'm going to indicate with an arrow that this is greater than. So all of these numbers from 9 all the way into infinity are part of this answer set. They're all possible answers for M. But I made a mistake. Do you see it? What needs to happen? Well, I need to color in this open circle here, because that indicates that M can also be 9 exactly. Why? Because of this second line underneath the inequality. That's what that means. This means or equal to. If it's not there, you have to write the open circle to indicate that it can't be exactly 9. It can be 9.0000000000000000001, but it can't be 9. Okay. They're going to do another one here for you. We don't need to do that, but let's do the solve and graph ourselves. Okay, I think what is confused, I have no idea what's confusing about this. Let's see. So what's happening to my y? And I want to isolate my y, right? So I really get a sense of what's going on. Well, they're adding 12 to it. So if I add a -12 to it, I'm all over the place, aren't I? Plus 12, -12, I'm going to get that y all by itself on the right side of the equation. But whatever I do to the left, I need to do to the right. I'm going to rewrite this. Instead of subtracting 12, I'm going to add a -12, although it's the exact same thing mathematically, only it'll make this a little bit more clear. So now I have a -12 plus a -1 on the left. Okay, this goes to 0. That's by design. I did that intentionally. And now I don't love how I wrote this. I'm just going to write it over here so we can really see what's going on the left side of the equation. -12 plus a -1. Is this a party or a war? Are the signs the same or are they different? It's a party because the signs are the same. What do we do when it's a party? We add them together. It's 13. We are adding. So how do we determine the side of the sum, the sign of the sum? We determine the sign of the sum when we're adding by, if the signs are the same, by adopting that sign. So in this case, we're adding negatives. The answer is going to be a bigger negative number. Notice that the rules are very different when we're multiplying. When we're multiplying, it's very simply, if there's one negative and one positive, the answer is negative. If there's two negatives, the answer is positive. It doesn't matter the size of the number, the value of the number. Notice here, I have two negatives and the answer is a bigger negative. It's because I'm adding and the rules are different. All right. So I'm at -13 is greater than or equal to y. 11, 12, 13. I'm going to draw an open circle for now. Now, which way does the line go? Does it go to the left or does it go to the right? We've been looking at these inequalities with the variable on the left-hand side. So if I move that variable over to the left-hand side, notice I can't keep the sign, the inequality sign the way it is. I have to orient it in this with that variable. All right. So these are equivalent statements. To say negative 13 is greater than or equal to y is the same thing as saying y is less than or equal to negative 13. The sign needs to flip. That inequality sign needs to flip. Okay, so negative 13 is greater than or equal to y would mean that this goes to the left. Because if I'm a bird, I want to eat the negative 13, not the y. And one more thing I have to do, I have to color this in because it is less than or equal to negative 13 y's. So any of these answers from negative 13 all the way to negative infinity, theoretically, are possible answers for y. That's our answer set. Wow, that was a lot. Sorry, I rushed through that, man. Here's an example. Here's another you try. I guess I'm trying to make these videos a little bit shorter because module 3 is really building to module 4 and 5, and we'll take a little bit more time with module 4 and 5. Okay, what do we got? A club has a goal to sell at least 25 plants for a fundraiser. Okay, so if I have some unknown, let's call this how much they're going to sell, and they want to sell at least 25. If they sell 25, are they good? Yeah, they are in terms of the context. So I'm going to add an or equal to sign here. Club members sell 8 plants on Wednesday and 9 plants on Thursday. What are the possible number of plants the club can sell on Friday to meet their goal? Okay, so we are already at 8 plants because that's how many we sold on Wednesday. And we sold 9 plants on Thursday. So my X is, I'm going to define that as the number of plants the club can sell on Friday to meet their goal. Clear? So 8 plus 9, that's how much we've already sold, plus X should give us at least 25. Meaning that this number, this sum here needs to be greater than 25. So what do? I can combine like terms. So I have 17, that's 8 plus 9, plus X is going to be greater than or equal to 25. I'm going to subtract 17 from both sides of this equation. If you want to think of this as adding a negative 17, that's fine. And I'm working vertically now so that you can see how that's done. This goes to 0, that's by design. And then I'm left with 25 minus 17, which is 8. So they need to, this club needs to sell at least 8 plants on Friday in order to meet their goal. Can they sell 10? Yes, it's greater than 8. They can. Can they sell 100? Absolutely. Can they sell 7? No. Why? It's less than 8. And I know this language is confusing because they're using the word least here. But you really need to think about it in context, right? So get an image in your head of what needs to happen and try to set it up mathematically as best you can. And if you make a mistake, you make a mistake and we move on. And notice that the question is asking for the possible number of plants the club can sell on Friday to meet their goal. If the question had asked for what are the least number of plants they can sell to meet their goal, the answer would be 8. But that's not what they're asking. They're like, what are the possible numbers? And that's anything over 8. X has to be greater than or it can be 8. All right, so that's it. That's the assignment. Boom. Let's go to our quiz. So if you haven't already done so, do the practice, do the discussion, pause the video, do the quiz, and once the whole lesson is done, come back to me and we will go over the quiz answer. All right, time for the quiz. Here we go. Yeah, so they're giving us PDFs now. I think this might be the first time we've seen this. The way to do this is either through Cami, open up the Cami app and annotate it directly. Alternatively, you can do it on a separate sheet of paper, take a picture of it and submit that separate sheet of paper. I'll reference back to the quiz to see what the problems are. Okay, solve and graph the inequality. So you've already done this. I'm going to add 4 to both sides. Why? Well, because if I use the bop rule here, if I think of this as adding the opposite, I need to get that -4 to 0. So I'm going to add its opposite, which is +4. And then whatever I do to the left side, I have to do to the right side. And I'm left with x is less than or equal to 3 positive. Why 3 positive? Well, is it a party or a war? I have a -1, I'm adding a +4. It's a war, so we need to subtract. 1 off of 4 is 3. We adopt the sign of the number with the bigger absolute value. In this case, it's a +4, +3. But that's not it. We're not done. Solve the inequality. We just did that. X is less than or equal to 3. Now we just need to graph it. So I'm going to do a really rough number line here. And one last thing I have to do, and that's color in this dot. Why? Because it's or equal to. That's what that second line underneath the inequality means. It means that it can also be equal to, and we indicate that graphically by coloring in the dot. It's the worst coloring in job ever, but I think you get my meaning. Okay. One more, solve and graph the inequality of 6 is greater than or equal to x. What's the trick here? Well, the trick is that x is on the right side of the equal sign. So sometimes that can confuse us, but don't let it. -4. Why am I subtracting 4? So that this becomes a 0. And whatever I do to the left side, I have to do to the right side. Boom. 4 off of 6 is 2, is greater than or equal to x. If this is confusing you, all you have to do is switch the 2 and the x. Just make sure that you reverse the inequality sign when you do that. So it would read x is less than or equal to 2. All right, but I don't want to do that for you right off the bat. I want to see if we could just figure it out. So here's my 0, here's my 1, here's my 2, here's my colored in dot. If I'm a duck, do I want to eat the 2 or the x? I want to eat the 2. That means all the possible values of that for x need to be to the left of 2. They need to be smaller than 2. If they were to the right of it, it would be bigger and I would want to eat that. But I don't want to eat that. It's smaller. So it's going to go to the left. How do I know it's smaller? Because the pointy side of the inequality is pointing to the x. It's on the x side. Yeah. Listen to that one 1,000 times. I know there's so much language here. All right, so that's the answer for number 2. Number 3, solve and graph the inequality h minus 2 is greater than +2. I'm going to add 2 to both sides. Why? Well, if I think of this as subtracting the opposite, I have plus a -2. So I need to add up the opposite of that, which is +2, to get it equal to 0. Whatever I do to the left, I need to do to the right. Boom. H is greater than 2 + 2 is 4. Still need to graph it. That's not a good number line. That's better. Here's 0, 1, 2, 3, 4. Does the duck want to eat the H or the 4? It wants to eat the H. So all the values I need to indicate graphically for the H need to be to the right. They're going to the right all the way up into infinity. Bloop, bloop, bloop. Okay, cool. So the one last thing we need to discuss is, do I color that in like I've done these two? I don't. Why? H can't actually be 4. This reads H plus 2 is greater than 2. It does not say greater than or equal to. That little line there indicates the or equal to. So I leave this dot open. One more to go, and then we are completo. That's funny. Let's see. The hard drive on your computer has a capacity of 160 gigabytes. You have used 122 gigabytes. Write an inequality that determines A, the amount of space available. All right. Well, I've used 122 plus A, and I have a maximum of 160. So does this side of the equal sign need to be less than or greater than the maximum? Well, it can't be greater than the maximum because that'll break the computer, right? So we are going to indicate this with a less than sign. Okay, it's not telling us we have to graph it. Okay, can it be equal to 160? Well, if it has a capacity of 160, I say yeah, it can. So I'm going to draw an equal sign there to indicate that, yeah, if it's exactly 160, we're okay. I think realistically we may not be, but in accordance with the problem, we probably can. So what should I add to this left side in order to make this positive 122 0 and get the A by itself? If you said the opposite of 122, you're right. If you said a negative 122, you are right. These first two terms here, this guy and this guy, are going to become 0, leaving A all by itself. Now, whatever I do to the left side, I have to do to the right side. What did I do to the left side? I added a negative 122. All right, this went to 0. That's by design, leaving me just with an A. It's less than or equal to 160 plus a negative 122. Is it a party or a war? The signs are different. It's a war. I subtract the number with the smaller absolute value from the one with the bigger one. That leaves me with 38. And I adopt the sign of the number with the bigger absolute value, in this case, a positive 160. So I don't need to write in a positive. I just assume it's positive if I don't see anything. So I have A is less than or equal to 38. The only other thing I might consider about this problem is we do have units here. And I might write them in because that would be a more correct solution. So A is less than or equal to 38 gigabytes. And we have finished module 3, lesson 2. Congratulations. We will go on to module 3, lesson 3 next week. And before winter break, fingers crossed, we will have built out all of these lessons. Thank you for being with me, and good luck to you.